Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schrankelberg.
And this is Dianna. Hi, Fred.
Hi, Dianna. Good to talk to you again.
Yeah.
We were chatting there for a moment and, talking about different projects you were working on and I'm, thinking about and stuff. And one of the things, and I don't think we've talked about it before, and I don't know that we've done many podcasts in general about it, but sample size, always a fun topic when somebody's trying to figure out, I need 687,000 samples to prove the 5 nines reliability of this resistor,
Yeah, it's always a question that comes up, and it usually comes out of nowhere, right? They're set up, they're all ready to go, and they think they're ready to go, and I go, how many should we test? And my answer is always, well, it depends. Let's talk a little bit more.
Yeah, I find kind of the high level take on sample size is my experience has been, in general, just broadly speaking, for many, many times running into this question, we will rarely ever get a statistically significant justified for what we initially say, oh, we really want. We want 99% confidence at 99.999 reliability over 5 years. Okay.
Yeah.
Do you realize how many samples you need for that? Oh, no. What do you mean? Well, we were going to test 2. Okay, you can want whatever you want, but the math works this way, and you pull out a calculator and run the math, and you need 8,797, whatever the number would be. And then they kind of look, well, what happens if we just run 2 samples? And I run the numbers and says, you have
it's 8,000 to 2.
Yeah. And it's what happens if we only have 2 samples? And he says, well, you're going to have a 10% confidence that you're better than 10% reliable, the way this test is set up and running. And they go, well, that doesn't sound very good. And I says, well, it's not. Let's try somewhere
between
different.
2 and 2,800.
Yeah. And it's always been, not always, there's a handful of cases where it worked out just fine. And it starts that discussion. What can we change to, what's acceptable? What's an acceptable failure rate that we need to detect? What's an acceptable change that we really need to know about? We might want it to be really precise, but that really jacks up the sample size. What if we relax that a little bit? What if it's 90% reliable? What point would you say we can't ship this? And then I try to back down. Well, what criteria is considered good enough? Not perfect, but good enough. And then if that doesn't do it, then it's pull out every trick in the book and try to do all kinds of other ways to get at it, given that we only have a handful of samples, and stuff like degradation testing instead of run to failure and stuff like that. Yet oftentimes you just don't get enough samples. I've run into medical organizations that tend to budget for it and do a lot of samples because they feel like they have to. But I don't know, what's your experience? Do you ever had a test run with as many samples as they initially thought they needed?
Well, yeah, being in medical device, and when I started in quality and reliability testing, I had really good mentors that really knew their stuff. I'm still so thankful that I, met up with those people. So when we said we needed so many samples, we were able to back it up with stuff. Yeah. But you're right. It usually starts out with the sense of I'm uncomfortable not knowing what it is I really need. Like you said, the 0.999627% reliability, Yeah. And there's either not enough information to make a better informed decision. So they don't know what they don't know, or they don't know where this is going to land at all. Or there's just this fear of not understanding what something that's less than that is, how that's going to affect the product.
Right.
So we were really good at tying that in with our FMEA and
Oh,
we would
interesting.
do our FMEA to evaluate what is critical, what has a high severity, or what's most likely to happen.
Hmm.
And we would pull those kind of failures out of our FMEA to justify what kind of confidence that we need for our test. So we use that analysis to help us think through, okay, what is it that really matters? Yes, we want to test this failure. Is this the most critical thing, or like what effect is it going to have on our customer, on the use of the product and its performance? And if it didn't have a whole lot of effect, then it made people more comfortable with reducing the confidence level. So and maybe sometimes the reliability, like we can afford for it to fail a little bit more. But at least it gave us some more information, even if we hadn't done any testing before.
Yep.
But that was the other thing too, is if they really had no idea, we would run some tests, some simulations with a couple samples just to see where we are with it.
Oh,
So
yeah.
that, yeah,
No, that's a good strategy in general. It's really easy to design a reasonable reliability or environmental test if you know what you're looking for. And I heard it one time, and I attribute it to Wayne Nelson, but he says he didn't say that. It was that the best way to plan a test is to have, run all your products to failure in the field first, so you know what you're looking for.
Uh,
you know, you need perfect
well,
information to know how to test for it
yeah,
perfectly. That's not feasible. I don't think too many customers appreciate that approach. It's the part of it is a understanding. I like the FMEA part. I've heard it done with hazard analysis too,
yeah,
and then it's actually set up as a policy. And that's what confused a whole bunch of people I've talked to over the years. Is, well, where does the confidence come from? Well, you make it up. What are you comfortable with? It's a signal of how much risk you want to take. And they're like, it's not like out of the book. No, this is where you get your big bucks here, manager. You tell us how close you want this number, and here's the trade-off. And it's just a set of discussions about, well, and then you run into one manager who goes, well, I'll take a lot of risk. Let's make it 50%. Like,
oh boy.
yeah, let's just flip a coin instead and say it's good or it's bad, because that's about what you're trying to say. And one argued that, well, it's just math. Let's make it 10%. I'll take a lot of risk. And I'm like, well, we have a pretty good chance then that our answers will be meaningless. And what do you
Yeah.
mean? What do you mean? Well, here's the math. you know, and I see that in vendor sheets all the time, as they say, well, it's got this criteria with a 50% confidence. I'm like, okay,
Really?
yeah, it's on component data sheets all the time. And that's kind of worthless. It gives you fewer samples. That's great. And they all passed. Doesn't really mean much, kind of thing. And I'm like, come on, you guys.
One of my mentors, he we set aside time every week
Mhm.
to talk about, he would give me problems, or I'd show him what I'm working on and that kind of
Mhm.
stuff. And and he drilled in. I had an aha moment with him with a set of data. It was for a sampling plan,
Mhm.
and we're looking at, I'm so concerned about excuse me, making a sampling plan that is going to be statistically significant.
Mhm.
And I'm digging, and I'm like beading, sweats beading on my face, kind of, there's a lot of pressure on determining what this is.
Right.
And he said, well, let's look at it though. Like, where is it performing with relation to what the minimum requirement has to be? And so we looked that up, and here this thing, with the initial tests that we were doing with it, like it was performing way above the minimum.
Yeah, it had a great
So he
margin.
said, practically, there's a practical significance here where we don't have to worry so much about the statistical significance because it's performing way above what it needs to do. So I remember that being an aha moment, that it's not
Mhm.
always about thinking about the statistics of it and the distributions and that kind of thing, but really, I guess that's linking it back to what's meaningful for the customer, how is it relating to the requirement itself. That's another one of those initial questions that I learned to ask when
Yeah.
anybody approached me. Like, how many should I test? Well, what's the acceptance criteria, and where is it performing right now? And
And how
that's another
well,
good way to start.
yeah, and how well do you need to know it? And we could
Yeah.
get a sample size that you'll know it precisely. You won't ship any units because you test every single one of them to failure. But what do you really need to know? What's the tipping point for you to make a decision? And before I forget, one scenario, I was working with a client and I was working on a subset of the overall system. And it was a little, just as a byproduct of the team I was working with, they were doing the little circuit board that connected to a remote control thing. Think of like a TV with a remote battery powered remote control. And it
Okay.
read that signal and it transmitted signals back to the remote control because it was a two-way device and it would get feedback on the device. And they had designed the product like 15 years prior, and they only reconfigured it if the shape changed because where it was getting stuck would have now needs to be long and narrow versus square or stuff like that. Same components, same vendors, very basic, very simple device. And it had 15 years of field service. And as far as anybody could tell me, none of them had ever failed.
Okay.
And they're doing million a month type volumes. And I'm like, okay, so they got it. The bigger system team hired a new reliability engineer, came right out of some military group. And he walked in my office all chest puffed out and huffy puffy, kind of, he needed a cigar to complete the ensemble.
Okay.
Kind of, and he goes, I understand you working with this thing and this is the device here. We've did the apportionment and it needs to be like 8 nines of reliability and blah, 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 blah. And you need to prove it with a demonstration test. And so I whipped out my little calculator. I actually had sample size stuff open on my desk on a spreadsheet. And I said, okay,
Oh, lucky you.
and I was working it with my team, because we had a brand new product, brand new thing that was going into a different product than this one. And I said, all right, you want what reliability according to that? And it was like a whole pile of nines. And okay. And what confidence do you need on it? I need 99% confidence. Okay. I don't even know what it's way beyond billions. It was just a great big massive number
For the sample size
for the
from
sample
your
size.
table.
Yeah.
Okay.
And I like, because he demanded that it be a binomial run it for the equivalent of the lifetime of the product, and which already was going to be difficult to do. And because we didn't know how it failed. We just hadn't seen failures. I mean, thermal cycling might eventually take the solder joints apart, but they never did. And so I said, no, we're not doing that test. Well, you have to. I said, no, I don't. Here's 15 years of field data that has, 100 million units that have successfully run for the life of the product until the customer retires it or trades it in or it fails for some other reason. And we've never had a recorded failure in the field of this. There's your answer. I'm not doing any testing for this. That's ridiculous. I don't have a budget to do that anyway. He says, well, you have to make a budget to do it. I'm like, you're asking us to do something that would completely wipe out this entire group's budget to make all the other components that we're making, all the other pieces we're making. I don't care. That's what you got to do. And it's, I followed him around the corner to our collective boss, and he was huffing and puffing that I was refusing his orders and blah, blah, blah. And I said, here's the math. And my boss, who is, I'm a consultant in the group, he goes, thanks, Fred. Bill, we need to talk.
Okay.
But
So what was the impetus of that, do you think?
He wanted every vendor, every component, every subsystem, everything to have a demonstration test so they could build a system model and see where they're at. He had no concept of the practical significance or what was the risk of this thing or anything else. And I was like, yeah, you're brand new to the system. Why don't you actually figure out where you need to spend your money? You only get $100, spend it wisely. And blowing a couple $100,000 on just the samples for a useless test is ridiculous. And he didn't like being shown up like that, so he never talked to me again, which was fine with me.
Yeah.
Well, there's a whole nother topic here. Is another client wanted me to do a design and accelerated life test for zip ties. The little, and they had 3 different vendors that were making zip ties, and they were particular dimensions, but you could buy them at a hardware store anywhere, kind of thing. And
Just the plastic ones that you feed the one end into the
yeah,
other and it locks. Okay.
yeah, and it locks, and it was to hold cables on solar panels. So the solar panels in a field would have 100 panels lined up, and then they would
Yeah.
run the cables underneath it to collect the electrons basically and run it down to where it went to an inverter and off to the grid.
Right. Okay.
And one of the things they found is that any truck rolls, the way they called it, out to the field cost them money. They're really designed to be, you build it and you wash it every couple of years and that's it. You clean off the surface of it. And even that is expensive for them to do it. But it's really supposed to be maintenance free. And what they were finding is that these zip ties they were using would break as wind and other vibrations would move that mass slightly. And then over time, those zip ties would oxidize and become brittle. And if
Yeah.
it failed, the connectors weren't, they used pretty cheap connectors for between these cables because they figured that they were attached with these zip ties. They weren't going to have any pull force on it.
Oh,
So a
okay.
zip tie failed and it would disconnect and you'd lose half your row of power. And
And that would be hard to figure out what's wrong with it then, right?
right, all of a sudden you get this big drop or a drop uh, of energy being produced. And so they'd run a crew out there and they'd walk the lines and go, oh, this isn't connected, connect it back in and zip tie it back up. And they're finding that that was a high Pareto failure mechanism for them. So they wanted an accelerated that. Which of these 3 vendors is best? My first thought was use metal. You don't use the cheapest ones.
Or yeah, or use yeah. Or I mean they make plastics that have
Better qualities and
yeah, well yeah, well, I mean the fillers in it that are,
right.
yeah, I forget what they call that, but
But there's stuff for UV protection and there's others for
yes.
elasticity and all kinds of stuff. And they're supposed to last 20 years is what they were aiming for. And they were getting failures at the 3 to 5 years. So they were, and the point is that I had an unlimited number of samples available. But that was still a real problem is I only had one way to test these things. So I could put a whole pile in an oven and or vibration or do whatever to age the polymers. And we knew the science of how they were aging and becoming brittle. So we could accelerate that. That wasn't a big issue. And so we had 3 different temperatures and we're setting up this test. The bottleneck was the ability to test it. We had an Instron machine for a tensile strength was the
Yeah.
technique we were
Mm-hmm.
using. And we had one tech and one Instron machine. And it took 5 to 10 minutes to sample one of them.
Yeah, it's so slow.
And so we, instead of the calculations and all the statistics, it was the practical measurement system constraint. Oftentimes it's budget constraint, but I could get 10,000 zip ties for $40, I think it was something like that. And so they were not worried about sample size. Yet when it came down to thinking through, well, how are we going to measure these things? Oh, I can only measure, 50 a day or something like that because of the time allotted for, we couldn't dominate that machine because it had many other uses. And they didn't want to buy another one for whatever reason. So it was like, okay, that's a real constraint. I need to think through how we're going to do this.
Yeah.
Sometimes it's space, sometimes it's the measurement system, sometimes it's the sample size. I've almost never run into a sampling discussion where there isn't a set of boundary conditions, constraints, types of stuff.
Yeah, that's true. Usually I think about from my experience, it's been mostly the cost of the unit or
Yep.
the availability of it.
Yep.
needing to make a decision about something that's not quite finished yet or not production equivalent or
Right.
but yeah, you make a good point that it's the also the test method. You're limited with that.
Yep.
Timing sometimes.
I had one that we needed to, the design of the test was we're going to measure the degradation. It was a wear pattern that would get deeper and deeper. And if it get to a certain depth, then it was deemed a failure. And it was like the size of a grain of rice, little titanium cylinder. And I'm like, how in the world are we
Oh
going to measure
wow.
that? And so we went to a failure analysis lab that had all kinds of ways to measure stuff. And they introduced us to an atomic force microscope. And it was basically this little itty bitty needle that would probe the surface. And it was like, if there were two atoms stacked up together, it would pick that out. It was, I
Wow.
don't think it was quite that precise, but it was absolutely amazing. And then so we made registrations keys on it, basically, that we could always align it pretty darn close, uh, hopefully close enough. And then we would take multiple tracks to map out the surface. And then it was, here's where it started, and here's the where in the first so many cycles. And so the distance it wore per number of cycles. And we were able to manage that. But when it was one of the tricks to, instead of going all the way to failure, which was also hard to read, or it would breach the inner surface kind of thing. And we could detect that with a simple microscope. It would take a long, long time to do that. And we didn't have that many samples. And so it was like, how do we get to failure faster? Well, if you can monitor the degradation and model the degradation rate to what you consider a failure, then you have perfect data. You have all failures. Now
Mm-hmm.
you can fit a distribution to it. You only need like 20 samples, 30 samples. Whereas if it was cycling to failure, it just took too long, even as fast as we could go. Yeah, there's being conversant and very adept at the math part of the sample size calculations, dealing with variance and precision or how accurate you want to detect it, and confidence, right? Each one has barriers and limits and so on, of what you can deal with. And that's not the end of the story. I think that's our gist of this
Yeah.
discussion.
Yeah, it really everything is there's not one good answer for any one situation. It's very situation dependent.
Well,
And and you mentioned too, you're measuring things. Just the test method itself can
mhm,
also introduce a variable that you need to consider with your sample sizes. That maybe the test method itself isn't that robust or precise as you want to measure it. So
yep.
that's sometimes you have to go back and fix that before you even start going into your test. But I guess that's getting outside of sampling and more into test methodology, right?
Well, it affects it. If you add a, say, 30% measurement error, that goes right into your variance.
Yeah,
And
it
in
eats it up.
order, yeah, and in order to detect what you think you're detecting, if it's measurement error, it really clouds it up. So if you put that extra measurement error into the sample size calculation, the bigger the variance, the more samples you need to detect a shift for any fixed amount of difference, what you're looking for.
Yeah,
Um,
we had a problem with that in one of the projects I had worked on that I forget what we were trying to measure. I think it was a chemical analysis. We had to mix a chemical for a test
mhm,
process. It was part
mhm,
of the test process. But just the variability introduced into that was a problem for us that we had to address with the way that we were sampling.
mhm.
And we were able to go back and reduce that a little bit, but I remember that being a big consideration in our test sample size. And there's also been the gotchas too, where we've been doing these kind of tests for years.
Mhm.
We're just going to use this generic protocol. But then when you're really looking at the test method and so yes, it has been used before, but now we're testing a different product on it. And how does that affect? our test method validation and the variance coming from our test method. And,
Yep.
and all of that had an effect on our sampling plans for our products, especially for the final verification test. Are we meeting requirements?
We're just teaching everybody listening to this. And somebody asks you for sample size, you're going to say it depends. It's just a natural response. I've learned try to not to do that because of the facial expressions I get from people. It's like, what? You don't know an answer? It's not just 42 and I'm good?
That was my usual. It's 42.
42.
Or the other
obviously.
one was 30.
Yeah, 30. Yeah. I don't know the units, but it's 30. They look at me like, what? Here's the considerations. And that's just for the statistics. And now we got to think about these other 10 things, from measurement system to test method to, budget and everything else. And, oh, by the way, who's going to use this information, to make a decision? Is this even relevant? Do we need to do it? I always, the best test by far is the one you don't do. If you really don't need to do it, don't do it. So I often go that way too. And anyway, there's way more to think about than what you find in your stats book on calculating sample size. And there's sample size formulas for all kinds of hypothesis tests and binomial testing of stuff and degradation testing and Weibull, regression fitting and so on. You can do the calculations. That's just the start. That's, I think, our bottom line. There's going to be a discussion. There's almost every time.
Yeah, it's not an easy question to answer.
No. And it does take understanding the mechanics of all of those considerations to come up with a valid or a useful or a valuable sample size that feeds into a test that will give you meaningful information. And I often do, it might be a whole other discussion, is, well, how do you know you're on the right track? And that's a whole different discussion, I think, for a lot of the things we do, especially statistics-based. But if you're listening to this, and you're thinking, oh, yeah, I get the sample size question all the time, how do you handle it? What kind of considerations do you typically have to take into account or deal with or trade off and so on? We'd love to hear it. And what questions do you have about it? I know we didn't cover everything on it. Let us know. Head over to accendoreliability.com/go/SOR. A couple of ways to get in touch with us. Dianna and I and the other hosts of the show are available through LinkedIn and our About pages. So plenty of ways for you to join the discussion, and we'd love to have you. I don't think I have to deal with samples today at all. It's a free day for a statistician.
Oh, yeah?
Yeah. No, you're not going to fix that now. We're going to hang up right now.
I don't know. Earlier this week, it was feeling like summer, and the initial thought that came into my head just then was, I'm going to go sample some ice creams.
There you go.
But now today it's like in the 40s, and I don't think I want to do that anymore. So I don't think I'll be sampling anything either.
There you go. Conditions change. All right. Well, thanks, Dianna, for the topic and the discussion. We'll talk to you again soon.
Okay. Thanks, Fred.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.